Right. Okay. 4. Is it okay? I think. Is it visible? Is it visible?
Yes, sir.
Okay. Right. I will start the regular classes. Right. Fine. Okay. So today topic is soil forming factors. So what are those soil forming factors? Definitely, if the soil want to be formed means few factors should be attack on the soil and they have to contribute something. Then only soil will be formed. So very first students, when the rock was weathered, the rock will convert it into regolith, small pebbles, bigger part of the rock will convert it into some smaller part of regolith. So the true soil will come from this regolith only. Okay, students. So naturally, if I want to say the very first, this disintegration and decomposition. Disintegration means all the compacted material will be given to small pieces, and those small pieces will be converted into another secondary compounds, next level of compounds by decomposition, like physical and chemical respectively. And the second step we can see, so after when this was completed, this first step of weathering, this disintegration and decomposition by this is by physical, this is by chemical. So by after completing this first step, the second step will be carried out by these factors. Those are called the soil forming factors. So if you want to say in a pictographic representation, this is a rock, this is a very rock form. You can see later on due to the disintegration and decomposition, you will get the regolith. It will be very in part of soil, and later on it will be converted into our true soil. It will convert it into our true soil. So very first is rock, and after by physical method and chemical some weathering process will take in place. Weathering process take and convert to regolith. And when the soil forming factors, the so-called soil forming factors, will act upon this regolith, and we will end up with our true soil, which we have seen in our day-to-day life. That is called the true soil. Now we will see what are those soil forming factors. Dokichov students, very first student. Dokichov is called is a renowned pedologist and is known as a father of soil science also. So he had given some soil forming factors in his view. What are those soil? So he said parent material. Given parent material is one of the factor, and climate is one of the factor, and plant and animal, that means biosphere, is one of the factors. So Dokichov has renowned this thing, but it didn't satisfy much. So what will happen later on? Dokicha is given this is a fact. Some plants means our regular parent material, climate, and organism biosphere as contribute are the important factors, he said. But this was not satisfied that much. Later on, what will happen? Our another famous scientist called Jenny or Eni in 1941 formulated the following equation. What he said? He said that soil forming factors are how many types? Now we will see. This is the soil, students. So what are the factors are important? What are the major soil forming factors? Very first factor is climate. Interesting. And another one is plant and animals. That is nothing but biosphere. And another one is topography, or even you can say relief. And another one is parent material. Another important factor, parent material. And another one is time, students. So these are the important soil forming factors, which was furnished by our great scientist called Annie or Jenny, the very famous scientist. He came across these ideas. So what are the soil forming factors, students? One is climate. Okay, you can come like this: parent material, climate, topography, time, and biosphere. Or you can come biosphere, plant, whatever. You just remember this. So in this also, student, there are 5 soil forming factors. Then naturally, these are all 5 soil forming. What is this? These are the factors: climate, biosphere, bioorganism, biosphere, relief, parent material, and time. And this dot something additional factors. So this is the 5. These are the 5 soil forming factors given by the Annie, very famous scientist. Okay, all these 5 factors, students, will act simultaneously, one after the another. They will act very fast. They will act simultaneously and produces our soil. Very important, very interesting, students. Very interesting, man. Now we will see it in detail about these factors. So before going to the next slide, I'm going to ask, can you classify these soil forming factors? I mean, There is one classification: active soil forming factors and passive soil forming factors. In this file, which one is called the active soil forming factors and which one is called the passive soil forming factors? Can anybody say?
Active
Active
biosphere
biosphere climate.
climate.
Okay. A set of students, you please come. JRF students, you say.
Active biosphere climate, sir.
Active, sir. What are the active biosphere and
Climate.
climate? Okay, and rest all comes under passive, right?
Yes, sir.
Okay. Okay. Anyhow, let us see whether is right or wrong. Now we will see that. Two groups in that. Passive forming factors. What are they? Passive forming parent material, yes, and time and topography. These are the passive soil forming factors. Okay, please remember, student, these are the passive soil forming factors. What are those? Parent material, time, topography are the soil forming, passive soil forming factors. Okay, and come to the next, active soil forming factors. What are those? Plants, that means organisms or biosphere, and climate are the active soil forming factors. So these are the two types of soil forming factors. Upon five soil forming factors, there are two types. They are passive and active. So passive are parent material, time, and topography. Whereas active soil forming factors are plants or by organisms, overall you can say biosphere. And another one is called climate. Okay, students. And if another, you can see wonderful of literature. If you keep your heart, the commitment, if you show on the soil science means, in this climate you can see different types of soils. You can apply many things upon this nature. Now we will see, students, what are those things. Very fun. You will see the passive soil forming factors. Okay, passive soil forming. Actually, these passive soil forming factors will provide the base for the active soil farming. That means these passive soil farming factors are the important soil farming factors. Actually, these give some base for the active soil farming factors. Now we will see what are those passive soil farming factors. Very first one is called the parent material. It's a mass, consolidated parent material from which soil is formed. So the consolidated packed form. I have already given what is a consolidated and consolidated. So the packed form, the form which helps in the soil forming. In this parent material, so there are two types, students. Sedentary. Can anyone say what is the meaning of sedentary? Sedentary, please. Anyone can answer. Sedentary. Okay, I think I'm not getting answer. Anyhow, sedentary means sedentary. They won't move. Formed in the original place. It will form in the original place. It is a residual parent material, and parent material different very widely from. So sedentary means nowhere it go. It will stay in the same part, on the same part. The parent material and another one material is there, which is transported. So parent material will be transported from one area to another area by means of some agents. So based on the transporting or depositing agent, the soils are classified in different technologies. We will see all those things. Very first, you will see some interesting things about this sedentary. What are those, students? Transported material. This is what I am saying. So some parent materials are transported from its original. Sedentary means those are the parent material which is formed. They won't move. They will sedentary life. Sedentary means will not move. In English literature, sedentary life means they won't move. It will stay only one area only. Whereas transported means they will transport according to the main forces. By agent of transporting, they have given different names according to the transport and depositions. So naturally, students, if it is gravity means, if the soils were completely deposited by the influence of gravity means parameter, that is called the colluvial soils. By the water, if it was transported by water means alluvial or marine and lacustrine. You will see what is the difference between these three. And by the ice means a glacial, even very similar words you can easily learn. And by wind means airline, you can see those are words. Now we will see all those things. So now we can see some animations. Here we come there. These are the rocks, students, rocks and minerals. So original material. Okay, after earth forming. So some sedentary, formed in the sedentary. So these formed in sedentary, these rocks, no changes. But what will happen? Residual parent material, there is somewhere moved. Some parent material, residual parent material is somewhere moved. Okay, and these two are combined, can be transported. What are those? Transported by water. If the residual parent material or even sometimes rocks are transported by water means what has happened? If that was deposited by the lakes means those are called the lacustrine. So students, sedentary is there, residual is the sedentary means same, residual means from here you can see some residual parent material. And if these are transported means what will happen? Transported by water means, and this depositions by the water in the water deposition in the lakes is known as leucostrine. This is called the leucostrine, and if it's deposited with streams, this is called the alluvium. This is called because it was same stream of water means that is called those soils are called the alluvial soils. And another one deposition by the oceans means those are called the. Can any idea, students? Deposition by ocean means
Marine.
any idea?
Marine.
Very good. It's the marine. Okay, deposits in the portions is called the marine. So lakes is called leucostrine, streams is called alluvium, and we can this you can see all these delta based all this type of soils we can see. And oceans means marine. This is by transported by the water. These are transported soils. But another mean is there transported by ice. Some glacier ice. Some soils were transported by ice also. What are those? Deposited by the ice means that is called the till. Okay, and if the till and or moraine and deposited by the water. This ice was again was deposited by the water after melting and deposited by water means those are called. And in the water also there are many types. Outwash, leucostrine, same repeated here. Alluvial, if the ice was melted and again was came out means called leucostrine. Alluvial by streams, and marine, same thing was repeated, deposited by the oceans. After when melting was happened, so this mostly transported by the water. Naturally, if it deposited by water means same thing was repeated here. But if it was deposited by ice means mostly we can say till and marine. And if the condition was like this, if it transported by the wind, all these things, if the ice or sometimes this one here in the intermediate also transported by the wind means here also something was transported by wind means those soils are called the deposited by the wind. So those depositions are called the aeolian. Wind depositions are called the aeolian. Okay, these are the depositions of soil, students. So these are the complete transportation of based on mode of transportation or agent of transportation. There we can see different types of soils. So definitely, students, whether it is SRF or JRF, definitely will get some questions on this. I think nowadays they are not asking the match the following, but some years back they are asking match the following based on this concept. Okay, so regarding the residual or sedentary parent material or even transported material, this slide will explain the entire concept of those three things. Okay, students, regarding with parent material is like this. So transported by water, transported by ice, transported by wind. This is all sedentary. Sometimes you can see residual parent material also you can see. So like this you can see many things. Now we will see endodynamomorphic soils. Does you heard, students, endodynamomorphic soils? Any idea about endodynamomorphic soils? Okay, I think yeah, you are not aware. Let's see. That means here we can see, students, the influence of parent material in the soils are slowly. The influence of parent material was very less in this type of soils. Mostly, the effect of climate and vegetation completely dominated the parent. Completely dominate the parent material. So this type of endodynamic soils are prevail only when the chemical temporary. They will perish only when the influence of this climate and vegetation high only. So this is called the endodynamic morphic soils. Here, the only thing is that here the influence of parent material was very less and was completely diminished or dominated by the climate and vegetation, which is again perish only when the chemical decomposition was very high. Only we can see this endodynamomorphic soils. We can see only this endodynamic morphic soils. We can see here the parent material influence was completely subdued by the climatic the things climate and vegetation, and these are very temporary students. These are only perish when the chemical decomposition was active. Only when chemical decomposition active only we can see this endodynamomorphic soils. Okay, this is regarding the endodynamic morphic soils. Coming to the next, students, ectodynamomorphic students. Here completely here also you can see influence of yes. Okay, here also you can see some, here also the influence of climate and vegetation will be there on a normal profile. But soil profiles are here you can see some parent material influence. You can see some parent material influence also you can see. But the parent material affects the profile and produce different kind of soils. You can see parent material the parent material influence will be there, but the parent material will produce different soils, especially in the initial stage when the soil was very very initial stage of soil formation stage means we can see this type of ectodynamomorphic soil, especially, students, acid igneous rocks like granite and rhyolite. Yesterday, yeah, there is some small mistake is there in while typing is there. I think I will send in those. I will explain later. So acid igneous rocks are there like granite and rhyolite produces very light textured soils. That is called the alpine soils. We will read this thing. We will read all these things in alpine soils, etc. Whereas coming to the basic igneous, we can say alluvium and colluvium derived from the limestone, etc. You can produce. So basic alluvium produces some coarse textured soils, and like that. And also, students, the nature of the element released, during the decaying of rocks, will produce special soil forming factors. During this decomposition or during this when the type of chemicals, type of ions, like suppose silicon aluminum was released, they produce secondary clay minerals. If the weathering, this is what I explained in this. The nature of the chemical releases during the decaying of rocks has a specific role in soil forming processes, especially when it was silicon aluminum forms. When this decaying releases silicon aluminum, you can expect some secondary clay minerals. At the same time, iron and magnesium are important, because this iron and magnesium also will impart some special color that influence that shows about the oxidation and reduction phenomena. And also sodium and potassium. If it was released by sodium potassium, you can see some deflocculate dispersing agent, and you can see some colloidal property we can see. And also if it is the magnesium and calcium is released, it means definitely those are useful for the plants. And also magnesium calcium are called the flocculating agents, students. There's a magnesium and calcium are called the flocculation agents. So those magnesium and calcium will give the stable structure. The aggregates will be very stable. Whereas sodium and potassium is called the dispersing agent, students. Definitely, of course, potassium is not that much. Generally, sodium is a dispersing agent, calcium is a flocculating agent. You will see, you will read many things about these two ions in problematic soils. Okay. So regarding with this here, also based the chemical, the release of based on the chemical reaction also, what are the chemicals released by the parent material also will be influenced. So this type of parent material influence will be there. That is called the ectodynamomorphic. So those parent materials also will show some different soils based on the parent material, like this. And what based on different chemicals, chemicals means based on different ions. Silicon aluminum means we can see some secondary clay minerals. For iron magnesium we can see some color, some red color, or that difference we can say oxidation and reduction phenomena. And if it is sodium and potassium means definitely we can say some humic colloidal and dispersing agent will be there. If it is calcium, we can say percolating and favorable stable soil structure will be there. And the stable structure sometimes improves the plant growth also. The same time, students, in next you can say relief. Okay. It is nothing but relief, topography, both are synonyms, students. It is nothing but configuration of land surface. Configuration is the structure of land. So topography refers to the elevation. Generally, you can say that refers to completely elevation of land surface. So generally, students, while reading this topography, there is one important word. One important word is there. Especially SRF students, you should say what is that word while we are reading with topography means. An important word is there. Any idea? No idea. Okay, I will give clue. It is start with soil. Next word is sea. It starts soil, sea. You feel that word, soil. Okay, I will say the answer. You please explain what is the meaning of that word. Soil catina. Have you ever heard about this?
Yes, sir.
What is the meaning of soil catina? Come on. Okay, SRF students, you should know all these things. Actually, this lecture is especially for you. And as same way, it is important for JRF students also. Please say, what is the meaning of soil catina?
Sir, arrangement of soil profiles. Same one.
Yes. Ramya, now you can say, what is that?
The soil is
Yeah, you can say, anyone can say. Yeah, what he said is right. You can see, while from this topography, you can see different horizons of soil forming. So that difference of horizon in one particular topography is called soil catina. Okay, students. Okay, now let's come to the lecture. We will discuss later on about why. So predominantly, students, this land surface also, this undulating surface, sometimes you can see soils are very quite different from topography to topography. In from flat to almost flat, you can see some type of soils. In undulating area, you can see something. In hilly area, you can see some type of soils. In mountainous areas, you can see some type of soils. So even based on this type of soils only, we will go for our LCC classification that we will read in next class. Next class means in after a few classes. Anyhow, students, FAO guidelines, Food and Agriculture guidelines in 1990, there have been some guidelines regarding the relief and topography. These are the guidelines, students. So flat to almost flat, the slope should be around 2%, some 0 to 2%. If it gently undulating means you can see that slope should be around 2 to 5%. If it is completely undulating means around 5 to 10%. Or rolling, you can see complete rolling will be there. Very deep slopes will be there. That is around 10 to 15%. But it's hilly means 50 to 30%. Steep distinct, very deep, very steep distinct means is around more than 30% with moderate range of elevations. We can say around more less than 300 meters. And if it's completely mountainous regions, fully mountains, all those things means we can see that is also more than 30% of slopes, but range of elevation is greater than 300 meters. So this is some sort of guidelines given by the FAO guidelines regarding what is the kind of topography should be classified. Now we will see many things about this topography like this one. So students, now I'm going to ask you soils on a flat and almost flat position. So now we are going to discussion. It's time for discussion. We should discuss the subject, then only we can get good ideas of it. What is the condition of soil on flat, almost flat surface? The soils are for what is the condition of flat soils? There is no undulations, nothing. Land was topography was completely flat, almost leveled. So what is the kind of soils you can find? What is the condition of soil in that position? Any idea? Any idea, students? Okay. How many of you are from plain regions? Plain regions means there is no undulations, nothing will be there. No one? Oh, come on. Okay, now I'll ask some general question. How many of you visited hill stations? So what kind of topography, what kind of climatic conditions have you observed in that position? No interaction. Okay, someone is trying to answer. Okay, students, I think
the runoff.
Not interested. Yeah.
In hilly areas, runoff maybe.
Very good. Hilly area runoff will be more. 1 point is there. Another important thing. Another important factor. Runoff will be more. Yes, you're right. Definitely. Oh, and another thing, do you observe any big stones and bulldozers? Big rocks and will be there in hill stations? Yes or no?
Yes.
Yes, sir.
I think Ramya should know. Ramya, have you ever visited the Nilagiri? Uti, Kodaikanal?
Kodaikanal.
So Kodaikanal, how the soils, how the conditions in Kodaikanal will be there? You know, while going that car, while we are moving our vehicles moving, you can see very deep slopes. You can see some small stones will be there. Soil was not there. If you clearly observe means definitely if you are nobody's the vehicles will be very ding dong. It will be very S-shaped road will be there. You can see in that hill stations all rocks, big rocks will be there. Even if it was heavy rain means definitely the road will be blocked due to the landslides. Some rocks all will be blocked. So that is the condition hill stations. Definitely runoff will be more. Yes, she had given good answer. And what is the conditions in plain area? Plain area means like Karaikal, very deep area, Karaikal, Chidambaram. Oh, I'm sorry, I'm talking more many things in South. Anyway, if you see is not most especially students, especially in Bhubaneswar, what kind of conditions we can see in northern states? Okay. Anyhow, I think I don't want to bore them you much. Anyhow, students, this is flat and almost flat land surface. What will happen means you will receive almost entire water will be received in that position. You know, for example, students, I'll draw some imaginary lines. See, students. So, okay, this is your undulating area. Okay. So this is very flat position, almost flat position. Okay. Here you will receive almost all the rainwater, all the precipitation will be received. So what will happen? Entire water will be percolated. Percolated will completely gone into the soils. Okay. But at the same time, here, this hilly station, this very topmost stations, especially this is what happening in Kodaikanal and Uti, even in Bhubaneswar and some parts of hilly areas in Bhubaneswar, some tribal areas also in Bhubaneswar, also it will happen. So what will happen? Most of the water will be drained off, will be leached off. So what will happen? All the soil materials will be gone deposited here. So you can see the distinct origination. You can see different horizons. You can see different soil horizons. We can see horizon. You can see depositions will be more here, and also you can see some distinct soil development. Here you can't see any distinct soil development because whatever the soils are produced here completely leached off. Okay, leached off and deposited here. So, and you can see some monotony. You can see similar level. You can see similar level of soil. You can see because everything was deposition here. There, deposition is more, but here you can't see that because everything was leached out. Nothing will be there. Only shallow and stony regions. Sometimes you can see some big stones will be there, and the soil profile was not that much great when compared to here. This is what happening here. This is what I was completely explaining this slide. Okay, students. So now we can see. You can see also mostly in this level, especially in this area, you can see the regional development that the climate regional was completely dominated. Such condition will represent it will give some representation of the regional climate. Completely it will represent the what is the climatic conditions of that particular area. And you can see different distinct origination. You can see what is the different profiles. You can see you can say that this soil is completely deposited from the heavy area, and in depth if you go into depth you can see another different development of soil because there's nothing is there, nothing is gone, everything was deposition only, nothing was washed out. No, and all the bases were settling here. You can see the soil was completely different from here when compared to here. Here the soils are very fertile, if you want to say, but here you can't expect nothing. That is the reason, especially in mountainous regions in Kodaikanal or in any hill stations like Kulu Manali, etc. You can expect only this type of topography only. So this entire thing, this difference of origination is called soil katina. This is what I am explaining. This is what I was expecting. Soil katina. This is the soil katina. This is what my main intention to say. Anyhow, student. So this is what complete I want to explain. So this is what I was explaining in the soil in almost flat positions, in undulating positions, students. In undulating position means you can see some ups and downs. You can see just previous slide now. In that position, you can see shallow, stony, very weakly profiles. We can't see much developed profiles. Profiles are very less because everything was going on. Everything was distinction. There were very less distinct origination. If you go and try to dig any profile in that hill station, undulating area, you can't see much origination because everything was gone. Everything was leached out. Nothing is there. And you can see some erosion due to the accelerated erosion removes the surface material. Complete surface material was removed before the time of development. Before it is not giving any time for development because whatever the particles were developed in the upper area was completely leached out to the lower area. And this reduces the water percolation. Due to this leaching out, there is no percolation of water as we seen in the flat area. In flat area, you can see complete percolation is there, but in here you can't see any percolation. In undulating area. There is no percolation. There is heavy surface because of surface runoff is there, and lack of water. You can't see any water there. Especially you can see in and if you go to Upasi, Upasi, there is one area Upasi, one plantation agency. In that area, the water was very scarce, but you can see heavy rainfall there. But water will not be stored because water is completely leached out. Runoff will be there. So there is no water. So there is no chance of growth of plants. So which is rather so here we have to we have to check the erosion and promotion of the soil formation to avoid all these problems. What is this? To improve the soil condition means we want to go for contour bunting. We have to check the soil erosion. We have to build some contour bunts to avoid the soil erosion, and also we have to grow some grassy vegetation on the hill area. Then only we can reduce the runoff and we can save some nature in the undulating topography. In flat position, there is no problem. Everything was given by the nature, and all the water will be there. You can see it very good, well fertile things. Everything will be happen. This is a distinction between soil forming flat and almost flat in soil and undulating topography. And you can see next slide in depression regions. Depression means lowland areas. Actually, this is quite suit for the one Union Territory of Puducherry. There is one area called Karaikal. In Karaikal, it is very lowland area. It is completely, you can see all the water will be stored there. Anyhow, we will see the depression areas in semi-arid, especially in semi-arid and subhumid regions, reflect the most of the conditions that actually observed in level of topographic positions, the addition of runoff, and all such conditions. Mostly this type of depression conditions you can see in Uttar Pradesh, especially Thare region, which I didn't visit, but very soon I may visit, and favor the most of the vegetation growth because you can see some moist conditions are prevailed, and you can observe all on level of topographic position due to the addition of water. You can there will be most addition of water will be there. Water receipt as a runoff because from the upper level as a runoff in the depression area you can receive a lot of water and result forming of component. And when this depression was happened in the depressed area, in the lowland area, when this water was received, you can see some dark colored soil rich in organic matter, especially in this depressed area. You can observe some type of soils called molly soils. There is one epipedon called mollic, yeah, mollic epipedon. You will read all those things, all the epipedon endopedons, which are rich dark rich in color, because in lower area what will happen means the decaying of organic matter, decaying of our plant residues are very slow because all the water will come and submerged all these things. And we can see some peat and muck level of soils we can see there in depressed area. In depressed soils were formed in the those depression. For example, I mean, this man. So this is your hilly area. You can see here you can see, but you can see some depressed area. In this depressed area, you can see all the water will be stagnated. What will happen? Whatever the plants, all the organic matter will be, the decomposition was very low compared to very high. So what will happen? The decomposition very low, and finally it will leave some dark color soil enriched with organic matter. So after when water was completely evaporated, we can see soils are very rich in organic matter and leave some dark color. So those actually that is one kind of epipedon that is called mollic epipedon. We will read this in next class. So regarding this sorry so regarding this so regarding soil depression and soil exposure and aspects, especially exposure means mostly by temperature, vegetation growth, and slope exposures. And also soils are facing some sunny and warming area, fluctuating in temperatures. You can see if the temperature is very high, definitely microbial activity is more and decomposition more. And mostly northern exposures of the on the other hand, and the cooler and humid in east and western exposures are intermediately positioned aspect. Generally, exposures means is nothing but exposing of to the temperature sun will give some another different kind of soils. So this is coming to this another important factor is time strength, which is nothing but the nature of time, or the amount of time, or the time that nature devotes to form a particular soil, or is termed as pedological time. Pedological time. It's called a pedological time. So completely matured profile. If you want to say any matured profile means that profile should have these three master horizons. Those are called the A, B, and C. Intermediate A and B, you can see all sub horizons, all you can see that you can read later. But you should see if any soil is completely developed means you can see that horizon should contain these three. A matured soil. What is those? A, B, and C. Okay, students. So time, generally the time taken for a particular soil development is called pedological time. And observe that rocks and disintegrate and decompose at different rate. Generally, all the rocks and minerals are won't disintegrate at the same time, or don't weather at the same time, based on the composition, based on the texture, structure, course. It will be differ from each mineral to mineral, rock to rock. Especially the coarse particle in limestone are more resistant because it contains some coarse particles are very less to the disintegration than those of sandstone. The coarse particles are very less decomposed, whereas in general limestone decomposes more rapidly. The coarse particle in lime are more resistant, but at the same time, lime decomposes more readily than sandstone. When compared to the sandstone, limestone decomposes very fast. But in limestone, some coarse particles will be there. That takes somewhat time. So, like this, each particle and nature of the nature and composition, everything will decide that how much time it requires to the decomposition. This is the importance. This is the fact, one of the important factor called time. So based on this, there are different stages are there. What are the stages of time? Well, very first is called initial, juvenile, virile, senile, and final. So these are the five different stages, students. at very first initial stage of time, that is called where parent material was not weathered. Nothing was happened. The original parent material was there. That period of time, that period of time is called initial. Whereas juvenile means nothing but just was started. Weathering was just initiated, but almost the original material was still unweathered. You can easily identify the original material. Whereas virile, you can see easily weatherable. You know, almost easily weatherable part was completely decomposed, and clay content was slowly increased, and you can see with some minerals were still appreciable. That means you can still identify some minerals. So if you see this type of features in any particular soil, so that part that soil in the stage of virile time is there, and senile time is nothing but the decomposition reaches the final stage. Only most resistant minerals are still surviving. In senile stage, almost everything was decomposed. Almost every mineral matter was decomposed, but very small amount of mineral matter, which are highly resistant, especially quartz, lignine. Only those particles only will be left out. Whereas final stage is nothing. Your final, just in the word itself will mention, complete soil was completely developed under the prevailing environmental conditions. So like these students, and during this period of time, you can see some new components will be introduced, some old components will be gone off, especially calcium carbonate may decrease or even lost when the time was going and continuing. At the same time, in humid region, especially in cold region, you can see the H plus ion concentration will be more. At the time of weathering condition, you can say H plus ion concentration will be more. Sometimes, if this H plus ion concentration is very high, the soils will, you can know the acidity content will be increased in this soil. So like this, you can see like this, the influence of this time is there, shows this much of importance in the soil development. So these are the 5 types of stages in time. I'm coming to the next, students. Soil forming factor, active soil forming factors. Now we have completed the passive soil. Now we come into the climatic conditions. So generally, students, all these things we have seen many things. You are from we are talking many things about the soil. We have seen weathering, what are the weathering conditions, and also we have seen some passive soil forming factors. All these soil factors, and in overall we get some idea. What are those? Moisture is very important. Temperature is very important. At the same time, composition of parent material is very important, and the undulating, that topography, everything. So all these factors are influencing what kind of soil was forming. So in that, active soil forming factor. So climate itself, it produces something. It is a dominant factor to recognize the soils. Because it produces some precipitation. Precipitation means it produces some moisture content. There are different type of climatic conditions, especially arid climate where the precipitation is far less than water needed. So almost we can see very dry conditions we can prevail. Mostly arid zone, we can see this type of climate. In humid conditions, we can see excess moisture will be there. So more water will be there. All the salts will be leached off. What will happen when all the salts was leached off? What will happen? The soil will become, base saturation 0 will become. So what will happen? The soil will become acidic conditions. Soils are become very acidic conditions. At the same time, oceanic climatic conditions. Here you can see some moderation. You can see there is some moderate variations in rainfall and temperature. You can see some variations we can see. And Mediterranean region, you can see some winters and summers are somewhat very dry conditions, and continental climatic conditions mostly, especially in South Indian conditions, are like this. Continental climatic conditions mostly, there will be warm summers will be there, and extremely cool and winters will be there. Summer will be very hot, at the same time winters will be very cold. This is called the continental climatic conditions. Okay, especially almost in nowadays in some Maharashtra, and even in Delhi also you can see this type of climate. That is different. There's a globalization, everything, that different kind of signs. And temperate regions, students. Temperate regions are cool and humid conditions with a warm summers, especially in northeastern regions. You can see all those things. And also tropical and subtropical climate, warm to hot and humid to isothermal conditions. And tropical zones, we can say tropical and subtropical. There will be hot climate will be there. Subtropical means some sort of hot, and tropical zones will be there. So like this, students, this climate will influence many things. So climate means it gives some moisture. So that is what we have read all these things here. Moisture means it will influence the microorganism content in that particular soil. So if there is limited moisture and limited temperature, means there will be more decomposition. More decomposition means more organic acids will be released. So these organic acids will act upon the parent material. So that parent material will release some nutrients. So those nutrients will be used up by the plants, higher plants. So like this cycle was continuing. So plants will grow and their roots will respirate. The roots will again release the carbon dioxide. That carbon dioxide again will combine with the water. That water again will produce some weak acid. That weak acid again will react the another clay mineral or something. So again it will release some nutrients. So like this, nature has its own buildup of very wonderful nature. Nature is very great. Like this, each and everything was linked up. So this regarding the climatic conditions and climate, this is just I already explained this for reading purpose. It affects directly or indirectly. Climate will influence. So directly how the said it supplies the water and also heat to react the parent material, and indirectly how it indirectly will supply, because when the moisture was supplied, what will happen? Flora and fauna, microorganisms, all animals will be furnished on the soil by using the energy source. So they will produce some organic matter. They act, so they will act upon the rock and minerals. They release some salts. Everything will happen. This is what I'm actually. So the climate will act both indirectly and directly. Coming to another thing, precipitation. Precipitation is just, this is a repetition, students. Nothing but the precipitation. When the water comes, it will dissolve with some other solution, some iron or some minerals, and the suspension will react upon the parent material, and it produces, and this will be go and relocated in other area. Sometimes it go on the upper, settle in the soil move to the upper. If the climate, if there is no rainfall was very less, means what will happen? It will go and settle. The evapotranspiration is more, so whatever the dissolved salts are there will come and settle upon the upper layer of the soil. So naturally, if the salts were came on the upper layer, you can see some salts will development, means those soils will end up with some salt affected. So that is a different issue. So same thing is what I explained. Temperature, students, temperature. Temperature influence more. High temperature hinder the process of leaching. Generally there is no leaching, will be not there. An upward movement of the soil, soluble salts will be there. If temperature is more, means what will happen? Temperature, all the soluble salts will be come on to our upward movement will be more high, and will be settlement will be there. So high temperature favors the decomposition, students, as I said earlier. So high temperature will decomposition will be more, so increase the microbial activity. So low temperature, what will happen? There will be induce the leaching will be there, reduce the evapotranspiration, and favor the accumulation of organic matter. The decomposition position is very low, and also what will happen? Temperature controls the rate of chemical and biological release, and temperature will show that much influence, especially in temperate regions. Temperature only microorganisms will survive or thrive in the soil environment. So temperature will show that much influence, especially in temperate regions, students, where the temperatures are very less. You can see accumulation of more organic matter because there is no decomposition. But at the same time, when you come to the tropical regions or another where the temperature is very high, you can say decomposition rate was very high because the microbial activity was very high. So like this, students, Jenny in 1941, he said, complete that tropical region, the rate of weathering process 3 times faster. He said that in tropical 3 times faster than the temperate region and 9 times faster than the Arctic region. So this is what he explained. So in tropical region, 3 times is very faster decomposition compared to temperate regions. And in Arctic, when compared to the Arctic region, 9 times faster, because Arctic can't expect anything. Everything was frozen. Nothing is there. So microorganisms are very sleeping mode. This is what the temperature influences that much in the soil. And coming to the organism, students, we have talked many things: humidification, mineralization. All the burrowing animals will be there. Some animals will dig for the surveillance. During that digging, you can see some influence will be there. Man also influencing, manipulating the vegetation by our daily day-to-day agriculture practices. We are creating new soils are there. New soils means if mostly destruction only. There is nothing development by using man. We turn most of the well fertile soils into salt affected, or good fertile soil turned into acid soils. Like that, we have created a lot of problems. And also compared with the traffic of man and animal, decrease the rate of water influence into soil. Thereby, when the man was in, when the human beings, we digging the soils much and more, means what will happen? There will be increasing of runoff there. Erosion will be more. Infiltration is very more. So like this, human beings also contributing something to the soil formation and vegetation, students. Yes, this is what I mentioned. Actually, I have mentioned because roots will be respire. Roots also will be respire. Roots will be respire, and they will release some carbon dioxide that will be joined with the water. Carbonic acid will be produces, and that will affect upon the clay minerals and release some soluble minerals. At the same time, grasses, especially when the grasses were grown, so these grasses will reduce the runoff and result greater penetration of water into the parent material. So what will happen when the grasses was growing very high? They reduce the runoff of water material. So when the runoff was reduced, what will happen? Water molecule easily join with the parent matter. That is called the hydration. So addition of water. So this is the importance of the vegetation. So that's all for today's class. Thank you, students. Any questions you can ask, and thanks for your patience. Any questions, students? See, we have to compare our lecture, students. We should not leave all the things, right? Very first day we have discussed about the earth. We have discussed something about our mother earth. At the same time, next day we have discussed about the crystallography, and next day we have discussed about the some rocks and minerals, and later on we discussed secondary clay minerals and weathering, and today we came the soil forming processes. So this is what we are learning day by day. We are learning how the soil was forming. If you want to learn many things, there is separate petrology. We read petrology means the many things are there. How the lava is there. Based on the lava, rocks were classified. How the rocks were, how the undulating surface rocks are formed, how the plane surface rocks are formed. So like that, many things are there. But this is not the correct platform to read all those things. When you get the chance in PhD or in MSc, you can read all those things. But our main target is to get a good rank, a nice rank, and should have a good perfect knowledge on soil science. Okay, students. Anyhow, students, but my only one request, please try to interact. Please speak out something. Then only the class will be interesting. Otherwise, it will be too boring. You know, just like I'm speaking something, and you are whether you're listening or not, I don't know because you are somewhere in remote area. Anyhow, students, thank you very much. If you have any doubts, you can ask now. I hope everyone have written the exam. Today, I will release the marks card, scorecard to your email address. Thank you, students. Any questions? Yeah, that's all. That's all, students. If you have any doubts, you can ask. Otherwise, we can leave the channel. Thank you very much, students. Please, we should interact. You are all completed BSc. SRF students were doing well. I hope, especially students, as you please see your syllabus. SRF students, you have the soil farming process. You should read many things. I'm giving some guidance to you. At the same time, you have to read. You may ask, sir, you promised you will give material. I will give, but I won't spoon feed you. That is wrong method. You should first of all you search something. You read, especially SRF students. How many of you reading Chagall book, textbook of pedology? Reading Chagall book means, I'm sorry. Okay, no problem. But it is good habit if you read that such a great author book means, because you are not in position to read DK Das. For JRF students, okay, they are very new to the subject. For fundamental, they should read DK Das, and so by reading some books, some fundamental knowledge is very important for them. But being an SRF student, you should have more knowledge on Chagall. You have to read very high level authors. Anyhow, students, any doubts, any questions? See, here now also you are not
No,
interacting.
sir.
No questions. Thank you. Thank you very much. Please try to interact. And not like dealing with big processes is a big problem. We are here for discussion. We have to discuss the subject. Then only it will be very interesting. One-way traffic means it's boring, nah? Because we are not like entomology, pathology, where I can show some insect image or I can show some plant. But soil science is not like that. I can set a tropical climate. Where I have to bring tropical climate? What image I can put in online class for tropical image? So we should have some interaction studies. Okay. Anyhow, students, thank you very much. Further, you can see this same class in YouTube also. I'll provide the link. Thank you very much, students. Thank you for your patience. I think tomorrow also there will be another class. I will say what is the topic later on. I think soil forming factors. Yeah, I think process will be there. Soil forming processes. Process means carbon, humidification, elevation. So like that we have many things. Okay. So within few days we will complete the pedology. And regarding with fertility, I think another my friend is there. He will deal with you. He's a PhD scholar from Coimbatore, Tamil Nadu, TNAU. he had a good knowledge on fertility. He will deal all those things. Anyhow, students, thank you very much. We can leave the channel. We have no doubts.
Thank you, sir.
I think Miss Rai, are you okay?
Yes, sir.
Because I'm not speaking much in Hindi. That's a problem.
No, no, sir. It's okay.
ठीक है ना?
I can understand. Yeah, yeah.
ठीक है. Thank you, Miss Rai. You can leave.
Yes, sir. Thank you, sir. Thank you.